11.1 Cubic and cube root functions. We're going to be working on the transformations. The first thing that you should notice that you have got A, B, C, and D here, which we have done quite a bit, so that part isn't new to you. What we do want to do is look at the parent function in the graphing calculator. If you don't know how to do an exponent, you got to use raised to and then hit your third power. I'm going to go ahead and graph this guy. Some students have told me it looks like part of a parabola. That is half of a parabola, and they took the other half and they reflected it down. That is true. Notice that it does hit 0, 0, and we want to make sure that we have a little graph of it here. You're just going to do a rough draft. So you're going to put 0, 0 there, because I can see that's going to hit. And then I'm going to go to the table, and I'm going to pick the point right above 0, 0. See, here's 0, 0. The point right above -1. -1 is right about there. And then I want the point below, which is 1, 1. It looks currently like a line, so make sure you look at the graph and you follow the shape of the graph. That is your parent function for a cubic x cubed, x to the third power. You can say it all of those ways. But that's your parent function, and we're going to be transforming it, moving it around with this bit of information. Most of us remember that this is our vertical shift. I can show you an example of that. If I take x cubed plus 2, if you watch this function, it moved from 0, 0, it moved up 2. Okay, so the same is true if I put -2, you're now, instead of going up 2, you're going to come down 2. Alright, vertical shift. That's beautiful. It works nicely. We're going to work with C. Notice C is inside a parenthesis. So we're going to do x minus 3. We're going to leave it like that. When we hit graph, instead of moving up or down, notice it moved to the right 3. This is our horizontal shift. It moved right, or it could move left. Horizontal shift. Notice that we have -3 in there. So we have a negative inside, but we moved to the right. So negatives will move you to the right. This is important. If I change that to +3, notice that I'm now going to the left 3. So positives move to the left. That's what you need to know about your C. Make sure that you don't forget that. Okay, we're going to go to A, so we're going to put a number in front. Notice A is at the very front. When I hit graph, my function has, it's not easy for y'all to tell. Let me put in, this function's a little bit stretched. It's hard to see it, but we do need to remember that -A, I'll show you that. -A is going to reflect over the x-axis. Notice I've reflected and come this way instead. If I take the parent out, you can see just the reflection from the parent. We've reflected over. We're going to have a vertical stretch or compress. Depending, we're going to stretch when we're greater than 1, and we're going to compress when we're less than 1. And so that is what A does. Now what's important is that we have a B, and I'm going to write that information over here because we need some space for it. B is the exact opposite of A, so -B is still going to reflect, but we are going to go over the y-axis this time. I will show you parentheses -x raised to the third. You have to put B inside a parenthesis. Notice B has a parenthesis right in front of it because B is being cubed. So, I still look like I reflected, but what we did was we reflected across the y-axis. It was down here, it came over, it was up here, it went over there. So it's a reflection across the y-axis. If I take that away and put the negative clearly out front, it does look pretty much the same, but they are two different reflections. One's going over the x-axis, one's going over the y-axis. Alright, the other thing you're going to have instead of vertical, you're going to have horizontal. Stretch and compress it. This one, again, is opposite, so A was greater than 1 for a stretch, B is going to be less than 1. You're going to do the opposite of what we see sitting here. So a quick example, just so that you have this, you're welcome to put it in your notes, is if I have this right here, sorry, you can't see it, this is definitely B. Notice B is right inside it, that parenthesis, in front of X. So this is going to cause me a horizontal. You have to look here. 3 is greater than 1, so we're going to compress. What's important is by how much. You always have to do the reciprocal, so it's 1/3. So we are going to write right here that you want the reciprocal. This is important for this function. So that is your transformations. We will do an example in just a second. However, what I did forget to talk about was when we looked at the parent function, which is right here, or right here, we need to come up with the domain and the range. The range is probably the easiest to see on this function because range moves from bottom to top, and you can see that I'm headed down, 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 down. So when am I starting? I don't have a starting point. I'm starting at negative infinity. You can see that I'm headed up forever, so I'm headed to positive infinity. You may also write this symbol, which stands for all real numbers. Domain. Remember, it comes from the left and it goes to the right. If I look over here at the left, eventually when I come down, I will hit this function because it's coming over. If I come all the way out here, I'll eventually find the function. So it doesn't have a starting point, so I'm starting at negative infinity. The same is true if I come all the way out on the x-axis to the right and I go up, I will eventually hit that function. So I'm going to be heading to infinity as well. Again, you just make 2 lines, you start at the back, and you can write that for all real numbers. If you'd like an example of how to do these graphs, I will work on this one problem with you very quickly just so that you can see it. Here we've got 1/2. If you notice, that's in A's place. It is outside of the parentheses, so we're going to have a vertical compression by 1/2. We're going to move to the right 8, and we're going to move up 4. So when I put that in my graphing calculator, I'm going to put in 0.5 rather than 1/2, just because that's easier for me. I don't know why it did this. Okay. 0.5 rather than 1/2. Oh, I forgot -8. Okay, and okay, and then I need +4. Now what we know is that we're taking this parent that started at 0, 0, we're going to move it to the right 8 and up 4. That should be our starting point. Let's look at it. Oh, we definitely moved over to the right, and we moved up. So we need to check the table, and we're looking for to the right 8. And you notice that that point is right there in the table. So I'm going to go ahead and plot it. That's my middle point, 1, 2, 3, 4. And I'm going to move to a point above. You may graph 7, 3.5. If you don't like it, go to 6, 0. The reason being you may not like decimals, but 7, 1, 2, 3.5 is right here. Totally up to you. You can have it or not have it. I need to go below 8, 4. I move to the right 8, up 4, so I'm going below that point. 9, 4.5, you can go there, or you can go with 10, 8. That is a big range. Again, make sure you look at the graph. Get your curve in right here. I missed that point a little bit, but there is your function. You will be doing an assignment over that. Then you're going to go back and you're going to work through the next function that we have, which is the cube root function. Notice we got x cubed, and I'm going to show you this really quickly. If you have x squared, the inverse of squaring something is to square root. When I have x cubed, the inverse would be to take a root, but you can't take the square root because a square root and a squared cancel. You have to take what we call the cube root. The cube root. When we take the square root of 16, that's 4 times 4, or -4 times -4. because you have to come out in pairs. When you take a cube root, we're going to put an 8 in there. You got 4 times 2. When you take a cube root, you have to be in a group of 3. You have to be in a group of 2 because this is a square root. I got to be in a group of 3. So the cube root of 8 is 2. So cubes and cube roots cancel one another out. So here I'm telling you that the cube root function, you're going to see this guy, the cube root, as its inverse. How do I put that guy in my calculator? Make sure you're in y equals. Make sure that you have cleared everything out, and you're going to go to math. And if you notice, number 4 is what we want. It says cube root. Hit enter, put an x in there, and then you can go ahead and graph it. This picture, instead of moving up and down like our last one did, this one still hits 0, 0. You can see it right there. And you go to the table, you still got -1, -1. There's 0, 0, and you still got 1, 1. So it looks at the start like a line, just like this one did. But when you look at the graph, you need to copy the shape of it. So we're going from side to side, we're going horizontally instead of vertically here. That would be the inverse. Well, vertically, now we're horizontal. Those are inverses. Okay, let's do the domain and range before I forget that while we're looking at the picture. This one's a little bit easier to see from the left. We're headed out here forever, so we're coming from negative infinity, and we're headed to positive infinity. Now, be careful on your range. Oh, sorry, you can also write all real numbers if you prefer. Range is bottom to top. Even though this guy's going to the left, he's also coming down slowly, but he's doing that forever. So we're coming from negative infinity, and as we slowly climb, we're headed to positive infinity, or again, all real numbers. Now, if you notice, A is in the same exact spot. B is in the same exact spot, in a parenthesis inside the root. C is inside the parenthesis, and D is at the back. None of these transformations change, so we can just write C above. They are exactly the same for both functions, because A, B, C, and D do the same thing no matter what function we discuss. Therefore, you're going to see the same thing. So let's do a practice one, because again, you will be doing practice of this. I will do this problem right here. So we're going to first of all state our transformations. We know that this one is going to be, let's look at this. Again, it is in front of the cube root, and in front of the cube root is A. So we're going to have a vertical, not stretch, sorry, compression by 1/2. You are going to move to the left 5, that's our C. You're going to move up 5 because that's our D. So we're going to go left 5, up 5, and we're going to go ahead and put that point. We know that the function should move up there. So let's go ahead and type it in. I'm going to do 0.5 again. Don't forget you have to hit math, number 4, and we've got x plus 5. Make sure you right arrow and hit plus 5, so this plus 5 is not under the root, just like it's not. I'm going to compare. Do you see how high up I moved? I moved backwards, and I moved up. So we're looking for this point in our table. -5, +5. So let's go there. Oops, going the wrong way. -5, +5. Hold on, let me go back in here and take this out so I don't confuse you. Okay. -5, +5. There it is. You can use -6, 4.5, because 1/2, you know right where it is. If you don't like it, oh, I would go with that, because you don't like that decimal for sure. -5, 5 is my middle, so I'm going to go with -4, 5.5. And then I'm going to make sure I go back to the graph, and I have to make sure I get the shape. You've got to come from below and curve up. That is graphing. That is the transformations of cube and cube root functions, which are inverses. I can show you x raised to the 3rd power, math 4x, okay, and then I'm going to go ahead and graph right in there y equals x, and I'm going to make that a a dotted line. I'm going to show you. There's your cubic. There's your cube root. And remember, we have talked about anytime things are inverses, you have a line y equals x, and they reflect over. If you look at this point right here, and I fold this calculator in half along this line y equals x, this point reflects over and is right here. This point reflects over and it's right here. This side of the graph right here would fold over and be this piece right here. They are inverses. I can tell on a graph because one function reflects over y equals x to create the other function. They are inverses. One function reflects over y equals x to create the other function. So I know that they are inverses mathematically and from a graph. Again, there will be assignments to complete and practice for this.